Alright, so what we have here is a block of mass m, 2 kilograms, on an inclined plane, angled at 30 degrees. It's got an initial velocity of 10 meters per second, and the direction of motion is up the inclined plane. And it's got friction, and the coefficient of kinetic friction here is 0.2. So for part A, we're looking for Fn, the normal force, and what we should do is draw a free body diagram of block M. So block M has gravity pulling down on it. Got the normal force perpendicular to the surface it's on. And it's also got friction. And because the direction of motion is up, friction is always opposing the direction of motion. It's going to be going down this way. And what I'd like to do now is split this into two other axes, the I-axis and the J-axis, so that we can break FG into its orthogonal components to make it easier to work with Fn and FF. So FG in the J direction is right here, and FG in the I direction will be right about there. So we're looking for Fn. Well, first we should find Fg. And we know Fg is the mass of the object times the acceleration of gravity. Mass is just 2 kilograms. And the acceleration of gravity is 9.8 meters per second. Do the math, this will come out to be 19.6. The units are newtons. So now I'll explain how we find FGJ. Right, so we know this angle right here is going to be theta, because the I direction, the I-axis, corresponds to the inclined plane. So these thetas will be the same. And if you just do some simple geometry, you know that this angle right here will also be theta. And the way we find FGJ, you just use some trigonometry. So we know cosine of theta, it's equal to opposite over adjacent, right? Oh, excuse me, adjacent over hypotenuse. So the adjacent side here is FGJ, and the hypotenuse, FG. And well, we just said that FG is 19.6, so cosine of theta equals FGJ over 19.6. So FG in the J direction equals 19.6 times cosine of theta, which is 30 degrees. Do the math, this comes out to be 16.97, and once again the units are newtons. And this is your force of gravity in the J direction. And we know that because the block is not moving up into space, it's not coming down through the inclined plane, we know that the sum of the forces in the J direction must be 0. So we do that. And we'll call this the positive direction, so we also know it's Fn minus FGJ, because those are the only two forces in the J direction. So Fn equals FGJ. We just found FGJ equals 16.97. So we know Fn equals 16.97 newtons. And that is your answer to part A. Now to find part B, well, the force of friction, we know that is equal to the coefficient of kinetic friction, because it's moving in this case, times the normal force. We're given the coefficient of kinetic friction is 0.2. We just found the normal force. And this equals 3.39 newtons. And that's your answer to part B. So for part C, we're going to use some energy calculations. The way I like to think about this, think about what the energy is before, or initial, whichever you like to say. So that would be the energy here. And the energy the block has after, which is going to be somewhere around here, right? Where it ends. So before, it's And we'll set this line right here as the gravitational potential energy to equal 0, so we don't have to worry about it in the initial or before case. And because it's moving, all it has is kinetic energy. Afterwards, when it stops, it's got no more kinetic energy, and all that kinetic energy has been transferred into potential energy, gravitational potential energy in this case. But we also must account for the friction that exerts a force on the mass. So we have to make sure we also account for the work done by the friction. And because everything here is going to be conserved, we know these two will be equal. So kinetic energy is 1/2 mv squared. It's going to equal GPE is mgh. And the work done by friction is the force of friction, vector, dotted with the displacement vector. So 1/2, the mass is 2 kilograms. The velocity is 10 meters per second. We know the mass is 2 again, 9.8. And the height, right here, this is the height. We'll call the distance it travels, that's what we're trying to find right now, we'll call that x. So, using some trigonometry, you find that h equals x times sine of theta. And theta is 30 degrees. And you're adding that to what the dot product comes out, because it's in the same direction, the cosine of the angle will end up being 1. So we can just say this is the force of friction times the displacement, x in this case, which is what we're trying to find. So on the right side, 1/2 times 2 is 1, times 10 squared is 100. This equals 19.6 x times sine 30 plus the force of friction we found previously to be 3.39. So 100, sine of 30 is just 1/2, 1/2 times 19.6 is 9.8. And you can just do the algebra from here, but in the end you find that x equals, 7.58 meters. And that is the answer to C.